We are moving on to lesson 7.4, day 2. We're going to do a little bit of review first. Remember, exponential equations are written in the form of y equals a times b to the x, where a is the initial value, b is the growth or decay factor, and this is a little bit new, but r is the growth or decay rate. When you are given an equation, you are given the factor, but there are times when they will ask you to find the rate. So for growth, the rate is equal to b minus 1. For decay, the rate is equal to 1 minus b. Remember, exponential growth is when b is greater than 1, and exponential decay is when it's between 0 and 1. So let's do a quick review of the first day. First, we want to decide if this is growth or decay. Well, we see that our growth factor is 2, which is greater than 1, so therefore it is growth. The factor is 2, that's where the b is at, and the initial value is 3.7. We know that in order to create a table, we're going to pick numbers -2, -1, 0, 1, and 2. Plug them in, and you can use your calculator. We're going to go ahead and move on to today's lesson, though. Example 1. Is the function exponential? Well, how do you tell that a function is exponential? So if we're looking at this right here, how do we tell that a function is exponential just from a table? Well, if it is being divided or multiplied by the same number every time, then it is exponential. If you look, 81 to 27, 27 to 9, 9 to 3, 3 to 1, they're all being divided by 3, therefore it is exponential. Then we have to decide if it's growth or decay. Well, to decide if it's growth or decay, as x increases, what is happening to y? In this case, y is decreasing, so therefore this is exponential decay. How do we find the factor? Okay, in order to find the factor, you are always going to divide up. Take the 1 divided by 3, and you get 1/3. Take the 3 divided by 9, you get 3/9, which equals 1/3. 9 divided by 27 is 9/27, which simplifies to 1/3. 27 divided by 81 simplifies to 1/3. It is important that you always divide up when you're trying to find the factor. So our factor in this case is 1/3. What is the initial value? Well, we know the initial value is when x equals 0. So in this case, my initial value is 81. So now in order to write our equation, we have y equals a times b to the x. So y equals a, which is our initial value, which we said was 81, times b, which is 1/3, to the x. And we've now written an equation for this first example, for this table, for this exponential function. Moving on to example 2. We need to decide if this function is exponential. Remember, the function is exponential if every time you divide up, you get the same number. So in this case, you are going to end up having to use a calculator. So you can take out a calculator and divide each of these up. 309.22 divided by 140.555 is roughly 2.2. As you keep dividing up on your calculator, 140.555 divided by 63.888, you're going to find a constant rate or a constant factor of 2.2. So, is this function exponential? Yes. Is this growth or decay? Well, as x increases, what is happening to y? y is increasing as well, so therefore it is exponential growth. Well, what is the factor? That's what we found here, that's 2.2. But now we need to find the initial value. Remember, we said the initial value is when x equals 0. But if you look at our table, we don't have when x equals 0. We have when x equals 1, 2, 3, 4, and 5. We need to know, though, what is the value of y when x equals 0. So we can use some problem-solving skills here. If we know that 29.04 divided by 13.2 needs to be 2.2, then 13.2 divided by the number when x equals 0 needs to also be 2.2. So we can actually take 13.2 divided by 2.2. Okay, because we are already at x equals 1, we need to go up one more to figure out what my y value is when x equals 0. So we need to divide up. So we take 13.2 divided by 2.2, put that in your calculator, and you get 6. When you write your exponential equation, you have y is equal to ab to the x. My a, my initial value that we found, is 6. My b is 2.2 to the x. Okay, we're going to go through one more example together here. So example 3. First we want to decide, is the function exponential? Well, how do we decide if a function is exponential? Divide up, divide up, divide up, divide up, and see if you get the same number each time. I'm going to save you some time here. Divide up each of these, so 19.2 divided by 30.72, you're going to get roughly 0.625 every single time you divide up. Okay, so is the function exponential? Yes, because there is a constant factor that is allowing our y's to increase or decrease. Now we have to decide if it's growth or decay. Well, as x is increasing, looks like y is actually decreasing, so that's going to be decay. Factor, well, we found our factor to be 0.625. That's what we found when we divided up. Exponential, or the initial value, is when x equals 0. But if you look, we know what y equals when x equals 2. So we can use some problem-solving skills here. If we divide 125.83 by 0.625, that will be when x equals 1. Then if we divide that one more time, we'll get all the way back to x equals 0. So 125.83 divided by 0.625 is 201.328, and that's when x equals 1. But we need to divide it one more time so that we can find out what it is when x equals 0. And that is 322.1248. So our initial value is 322.1248. So now when we write our equation, we have y is equal to a, which is 322.1248, times b, which is 0.625, to the